For most of Wi-Fi's life, each new version had a technical name, like 802.11b or 802.11ac. These names came from a group of engineers who set the rules for how wireless connections work. They were never really meant for regular people. They're just internal labels that ended up on product boxes. Then in 2018, a separate group called the Wi-Fi Alliance, they're the ones who approve and certify wireless products. They decided to give everything simpler names. Wi-Fi 4, Wi-Fi 5, Wi-Fi 6. They went back and renamed the older versions too. Wi-Fi 1. The first generation, now called Wi-Fi 1, came out in 1999 and it ran on something called the 2.4 GHz band. A band in this case is just a range of invisible airways that the signal travels through, the same way radio stations each have their own frequency. And this particular band, 2.4 GHz, was good at traveling through walls and across a room, but it could only carry a small amount of data at a time. The top speed was 11 megabits per second, which was roughly enough to load a basic web page, but nowhere near enough for anything like video streaming. Wi-Fi 2. Wi-Fi 2 came out around the same time and it tried a different approach. Instead of 2.4 GHz, it used the 5 GHz band, which could carry a lot more data, up to 54 megabits per second. But 5 GHz has a problem, and it's one that comes up again and again throughout Wi-Fi's history. It doesn't travel as far and will slow it down a lot more. So even though Wi-Fi 2 was faster, it was also less reliable across a normal home, and most people never really used it. Wi-Fi 3. Wi-Fi 3 came out in 2003, and this is the one that actually made it into people's homes. It ran on the 2.4 GHz band, so it had good range and more coverage than Wi-Fi 1, but it also matched the Wi-Fi 2's top speed of 54 megabits per second, and that combination was good enough to make wireless internet feel like something worth having. Laptops started coming with Wi-Fi built-in, and coffee shops and airports started offering wireless internet, and the whole idea of connecting without plugging in a cable started feeling completely normal. That was a big shift, but there was a growing problem and it only got worse every year. The 2.4 GHz band has a small number of channels. Think of them like lanes on a road, and as more and more devices started showing up in homes and neighborhoods, they all started sharing those same lanes. More devices meant more traffic, and more traffic meant everything got slower. Wi-Fi 4. 2009. Wi-Fi 4 came out, and this is where things really started moving forward. The top speed jumped to 600 megabits per second on paper. And even though real-world speeds were lower than that, the difference was still huge. Streaming HD videos, which was just starting to take off, finally worked reliably over a wireless connection, and that changed how people use the internet at home. But the bigger change was something called MIMO, which stands for multiple input, multiple output. Before MIMO, a router and a device talked to each other through one antenna at a time, like a two-lane road where only one car could go in each direction. MIMO added more antennas on both sides, so several streams of data could travel at once, and the result was that connections felt faster and more stable, especially when more than one device was on the network. Wi-Fi 4 also introduced something called dual band, which meant a router could broadcast on both the 2.4 GHz and 5 GHz at the same time. So devices that were far away could stay on 2.4 GHz for the range, and devices that were close to the router could jump to 5 GHz for the speed. That flexibility made home networks noticeably better, and it also helped ease the congestion problem that had been building up on the 2.4 GHz band. Wi-Fi 5. 2013. Wi-Fi 5 arrived, and this was the version built for a world where everyone was streaming video, gaming online, and connecting more and more devices at once. The top speed climbed to 3.5 gigabits per second, and to put that in perspective, that's fast enough to download a full HD movie in under a minute on a good connection. Real-world speeds were lower, but even so, wireless internet started feeling genuinely fast rather than just enough. Wi-Fi 5 also improved on MIMO, with something called MU-MIMO, and the MU stands for multi-user. The original MIMO could only talk to one device at a time, even with multiple antennas. It switched between devices so quickly it felt like it was doing everything at once, but it wasn't. MU-MIO let the router actually talk to several devices at the same time, genuinely in parallel. And in a home where a laptop, two phones, a TV, and a gaming console were all active at once, that made a real difference. Each device got attention without waiting for the other to finish. The one thing Wi-Fi 5 didn't fix was range. Its high-speed mode only worked on 5 GHz band, which is fast but still struggles with walls and distances. So devices on the other side of the house often ended up on a slower connection, and that frustration stayed with a lot of people right through to the next generation. Wi-Fi 6, 2019. Wi-Fi 6 came out, and this one is interesting because the biggest improvements weren't just about going faster, they were about going smarter. The top speed went up to 9.6 gigabits per second, but the more important story was what happened in busy places. Wi-Fi 6 introduced something called OFDMA, which stands for Orthogonal Frequency Division Multiple Access, and that name is not important, but what matters is what it does. Before this, a router gave its full attention to one device at a time, even if that device only needed a tiny bit of the connection. OFDMA let the router split its attention into smaller pieces and send them to different devices all at once. It's like a delivery van that used to drop off one package per trip, finally learning to deliver dozens of packages to different homes on the same route. And the result of that in real life is that Wi-Fi 6 works noticeably better in crowded places, apartments, offices, stadiums, anywhere a lot of devices are competing for the same airwaves. Also, Wi-Fi 6 introduced something called target wake time, which let devices schedule exactly when they check in with the router instead of staying alert all the time. And for phones and smart home devices, that meant meaningfully longer battery life just from being connected to a Wi-Fi 6 network. Wi-Fi 6E. Not long after Wi-Fi 6, Wi-Fi 6E came out, and it's the same thing with one important addition. Wi-Fi 6E opened up the 6 GHz band for the first time. And that was a big deal because the 6 GHz band had barely been used by anyone before. It's wider and far less crowded than 2.4 GHz or 5 GHz, so devices that can access it get a much cleaner connection with less interference from everything else around them. The catch is range. The 6 GHz signal doesn't travel as far as 2.4 GHz, and walls affect it more, so it works best when you're close to the router. For open spaces and newer homes with mesh networks where several small routers are spread around the house, it's great. But for older buildings with thick walls, the benefit fades quickly. Wi-Fi 7, 2024. Wi-Fi 7 is the newest version, and it's also the biggest jump since Wi-Fi 6. The top speed reaches 46 gigabits per second on paper. And even though real-world speeds won't hit that, the gap is still significant for anything that needs a lot of bandwidth at once. The biggest new thing is something called multi-link operation. Every version of Wi-Fi before this could only connect on one band at a time, either 2.4 GHz or 5 GHz or 6 GHz. Wi-Fi 7 lets a device connect on more than one band at the same time and use them together as a bigger combined connection. So a laptop could be pulling data through 5 GHz and 6 GHz simultaneously. And if one of those signals weakens because you walked into a room, the connection just leans more on the other one without dropping. Also, Wi-Fi 7 doubles the channel width on the 6 GHz band, meaning more data can move in a single go, and it increases the number of parallel data paths between the router and a device from 8 to 16. And all of that together means Wi-Fi 7 is fast and reliable, all at the same time, which previous generations were always trading off against each other. For most homes right now, Wi-Fi 6 is still more than enough, but Wi-Fi 7 makes a real difference in places where a lot of people are all using a lot of bandwidth at once. Offices, shared apartments, or anyone streaming 4K while gaming while on a video call. Wi-Fi started as a way to avoid running cables through a building, and now it's fast enough and reliable enough that most households don't need anything else. Every generation fixed the last thing one couldn't: speed, then range, then congestion, then efficiency, and then all at once. Wi-Fi 8 is already being worked on, but for now, Wi-Fi 7 is as good as it gets.